Hello, grade 8 math. This is 6.5, solving equations involving the distributive property. As we learned last lesson, the distributive property is that A times the sum of B plus C is equal to A times B plus A times C. So the first term here multiplied by what's outside of the brackets plus what the second term multiplied by what was outside the brackets. So A times B plus C equals A times B plus A times C. And we showed that this works. And sometimes it's good to use this method to solve an equation, and other times it's this. So we're going to use these things where we are able to expand and evaluate, and we're going to then solve some equations using this. So you'll get some questions that say solve using the distributive property and then verify at the end, just like we've done in previous assignments. And you might get something like this example. So we might get this: 5 times the sum, meaning the addition of t plus 2 equals 30. And to solve this, what we're going to do is notice that if we apply this distributive property up here, our 5 is this term that's outside of the brackets being multiplied by the brackets, which is 5. The t would be our b, right? And our 2 would be our c. Okay? So what we're going to do is we're going to take these terms and we're going to distribute them this way. So we're going to take our 5 and we're going to multiply it. I'll leave a little bit of space there. 5 times our b term, which is t here. So it's 5t, 5 times t. And then we're going to add it still, right? Because that's what's next, to our a term, which a term was 5. And our c term is what we add next, right? It's going to be AB plus AC. What's c? It's that 2. So it's going to be multiplied by 2. And that equals 30. Then we just go and we solve. We know how to do this. It's going to be 5t still plus 5 times 2. What's 5 times 2? Well, 5 times 2 is 10. That equals 30 still. Okay, so we did this part right here. And then we still have 5t plus 10 equals 30. Well, to get rid of that plus 10, this is what we were doing earlier in the unit, where we get rid of something from one side and get rid of it from the other. And we're left with 20 over here. These cancel out, right? And we're left with 5t. So 5t equals 20. And what do we do next? We divide both sides by that 5. We divide both by that 5. And what are we left with? We're left with the t equals 20 divided by 5. And t equals 20 divided by 5, which is 4. So t will equal 4 as our answer. But just because we've got this answer doesn't necessarily mean it's right. We need to verify the solution. So what we're going to do is take this first equation up here, this very first one, and we're going to write it down. So 5 is what we started with, times t plus 2 equals 30. Okay, we start with that same equation that it gave us as a question, and we're going to put t in as 4 where it was. So this then becomes 5 times 4 plus 2 equals 30. Notice that this is what we replaced. T is 4, so t goes there. And then we just solve. This is 6 equals 30. 5 times 6 is 30, which equals 30. And it verifies. Just realized I didn't slide it down there. So we added the things inside the brackets, following bed mass, which is 6. And 5 plus 6 times 6 is 30. 30 equals 30. Now, this method that we used to solve for t and got t equals 4, there's actually a faster way to do this. that doesn't use the distributive property. And sometimes it can be actually quite a bit easier. In this case, it would actually be easier, but it takes kind of understanding and seeing the math maybe a little clearer. And there are some times where this might not work quite as well as doing the distributive property. And this lesson, just because there's this way that I'm about to show you that lots of the questions you'll get are easier, I still want you doing it this left side, using the distributive property to practice it so that you actually know this, so that if you get something maybe this way, you'd be able to switch it back after. So there are some reasons to do it one way or the other. Now, if we look at this, we've got this term right here, t plus 2. But let's just pretend that t plus 2 was like some random other number, right? It would be 5 times that number, right? It's 5 times that. So what you actually can do is something neat here, where notice that this term here, this 5, that I'll kind of highlight a bit in green, that 5 is something that's multiplying by everything else on this side of the equal sign, which means that we could actually divide by that 5 here, and it would cancel out. But if we're going to do that to this side, we also have to do it to this side. So we're going to do that. And what are we left with? Well, we're left with t plus 2. And because that's the only thing on this side, you don't need the brackets anymore. And that equals 30 divided by 5, which is 6. And then look how simple this is. We go subtract 2 from both sides. We end up with t equals 4. Now, just because this way is simpler doesn't mean that you should do it on this assignment, because we are practicing this other method and there is a reason for it later on in math. For example, let's say this number 30 couldn't easily divide by 5. You'd be left with some decimals, and then you'd have to subtract from those decimals, and that's where it does become more complicated and maybe it isn't as easy to do the mental math. Whereas if you do the distributive property, you are able to potentially do the mental math the whole way through. And so being able to know this conversion back and forth between one side of the distributive property and the other is important, so that you can do calculations even without a calculator or a piece of paper. Notice that we still got to the same answer going either way. So if it says to use the distributive property, please do it on this assignment. If it doesn't say you have to do it that way, you could do it this other way on later assignments. And to verify is just what we've been doing in other times, so the verification would be essentially the same thing we had down here if you did it this way. All right, here's another example, word problem, real life kind of thing. Martha sells lemonade. She begins the day with some money. As well, on the way to work, her mom gives her $5. A few hours after beginning work, she triples the money she had at the start of the workday, which includes that $5 that was given. Write an equation, use it to solve how much she had before her mother's gift, and verify after. So, Martha has some money that we don't know what it was at the start of the day, right? Let's use M for money. So our equation is going to M for money. And we found out that her mom gives her $5 more. So add $5 to that money. Now that's what she starts her workday with. Why? Because the workday starts when she gets to work, and on the way to work she picked up that $5 and she already had some money. And then we find out after she works for a little while, she triples the amount of money she has. So she triples, which means 5 times all of this money. It's all of that money. I'm just realizing I skipped a little line that I wanted to do. When she triples it, she now has $36. Okay, that's an important point. So triple her money, which should be a 3, not a 5. She triples her money that she had at the start of the workday, which is the money she had before she went to work, plus the $5 that she got on the way to work, is what she started the workday with, and then it's tripled. That equals how much? 36. So there's our equation. Now, one way to solve this using the distributive property would be to take 3 times m plus 3 times 5 equals 36. 3 times 5 becomes 15. And the 3m's still there. Then subtract 15 from both sides. This becomes 21. This is 3m. And then divide both sides by 3. And you end up with m equals 7. You could have solved this another way, though. You could have also gone 3 times m plus 5. And before you even did that other method, you could have thought, well, can 36 divide by 3 evenly? It can. So let's just divide both sides by 3, the whole thing. We're left with m plus 5 equals 36 divided by 3, which is 12. Then subtract 5 from both sides, and we end up with 7, m equals 7. If it says to use the distributive property, you have to do it this way. If it doesn't, you could do this way, except on this assignment, I want you to practice this way. But I'm showing you this because you are allowed to use this in future assignments. And then it says to verify. So let's take the original equation. 7 plus 5 equals 36. And we're left with 12. 3 equals 36. 3 times 12 is 36 equals 36. It is verified. So how much did she have? She had $7 on the way to work. Her mom gave her a gift of $5, and then she tripled that and ended up with $36. I should say the question didn't have a question mark in it, so we won't do a sentence to say that. Here's an example. What about 14 equals 3 times x plus 4? Well, looking at this, I'm not going to use that way that's a little bit quicker like this. I'm going to realize that 14 doesn't divide by 3 quite evenly, so I'm going to distribute. And we've been distributing on the left side, but you can also do it on the right. You can keep 14 there equals, and you can go this term that's outside the brackets that's being multiplied by it, 3 times x plus 3 times 4. And we'll take 3x plus 12 is 14. We can subtract 12 from both sides. Subtract 12 from both sides. Here we go. We are left with 2, and it's 3x over here. And then we're going to divide by 3. Divide by 3. And we are left with x equals 2/3, or 0.6 repeating. So when you end up with these fractions or decimals in your answer, those are the ones where it's not so easy to do that way, where you divide, because then you're going to have a bunch of calculations with repeating decimals, and those repeating decimals, if you forget to keep those, you're not going to get to the exact precise answer of 2/3. You'll just be almost 2/3. So that's why the distributive property is important. Now to verify, we take 14. Oh, I forgot my 3. 3 times x, which is 2 over 3, plus 4. So 14 equals, well, let's do 3 times 2/3. Let's use the distributive property to actually verify this. And we'd have 14. Well, 3 is being multiplied and divided. That means it's just 2, plus 3 times 4 is 12, and 2 plus 12, I almost wrote what I was saying, is 14. So 14 equals 14. So even within verifying, you could use the distributive property. And that's actually where I use it the most later on in math. If I remember correctly, in high school, that's where I'd use it more often. I'd like to do one here that's maybe just a little bit more advanced. You'll see this maybe on some bonus questions, but you won't see this as the ones that will be for marks for everyone. But I'd like to just do a question where, you've got something more complicated. It's not just a single number being multiplied here. What we know about multiplication is it doesn't matter the order that you're multiplying in, right? So what I'm going to do here is I'm actually going to flip these two. And I'm going to move x subtract 4, this part here, and I'm going to cross it over with this part here. Okay? It's still going to be equal. Okay? This is going to look kind of confusing there, but I'm just taking those terms that are being multiplied by each other, because that's what it means when brackets are touching another group of brackets. And I'm just going to flip the sides. And then what I'm going to do is I'm going to take negative 3 and add it to 7, which that equals 4. And once I just have one digit there inside the brackets, I can just get rid of the brackets. So I'm left with x subtract 4 equals negative 24. And then, now this looks just like those other questions we were solving. And in this case, you know, I could divide by 4 on both sides and actually be pretty easy, or I could distribute. And since this assignment's about distributive property, I'm going to distribute. And now, remember, when there's a negative sign in here, what you can do is do a negative, and then you just multiply these two things by each other. So it's going to be 4 times 4. And it equals negative 24. So 4x subtract 16 equals negative 24. We're going to add 16 to both sides, add 16 to both sides. We are left with 8, negative 8 I should say, and 4x. And then we're going to divide both sides by 4. We're left with x equals negative 2. And let's verify this. Let's take this first equation and let's put x equals negative 2. So we're going to take negative 2, subtract 4, negative 3 plus 7. I'm just writing down that same thing again. That's what verifying means to do. And then negative 2 times subtract 4 is negative 6. Negative 3 plus 7 is 4 equals negative 24. And what is negative 6 times 4? It's negative 24. So it is verified. Again, this example is more complicated than you'll see on assignments, except a bonus question here or there. And I do want to just point out a common misconception, meaning something people get wrong often. People will often do things like this, where they're like, oh, we think that this means 3s plus 7 equals 30. So they just got rid of the brackets. But what they forgot is that this 3 with these brackets here, with this stuff inside the brackets, the s plus 7, this 3 is being multiplied by all of this. It's not just being multiplied by s, it's multiplied by all of it. And so what's missing is this part that I'll put in purple right here. It's that you need to multiply 3 times 7 in there. So don't get that mixed up. Let's just solve this one just to be safe. This becomes 21. 3s plus 21 is 30. Subtract 21, subtract 21. We're left with 9. 3s. Divide both sides by 3. This is that math we were doing before, and we get 3. All right, so don't get confused by that. You need to distribute that 3 and multiply it by each portion inside these brackets. I hope this helped you, and have an awesome time doing your lesson assignment.